Hi, Professor NTA. This is my video for my assignment 3. And here is all the fields for my this assignment. And let's begin. For the first task, we need to choose 3 data sets. And I will show you the code. Okay. In this task, we use the sklearn datasets to import the areas and the database and cancel these 3 data size and use pandas to show the information of data size. Okay, this is the result. We can sort the number of symbols, the number of filters. And after that, in the task 2, we need to apply a prediction on this data size, which all weak linears, including the KNN, SVM, BS, and at last 2 decision trees, including the ID3 card and these 2 we choose. I choose the uh, ID3 and cars, and we can solve the uh, distribution of the uh, data size of their bits. Suggests us to use SVR uh, to do the analysis. So I end the regression model in my code, and let's run the code. Okay, here we can solve the result about weak linears and the regression for database dataset. Okay, for the code details, we first split the dataset into training side and testing side. For the 17% and 30%. This is 10-fold cross validation. We split we use the key fold, and in the key fold is from the sklearn model selection, and the cross will score from the sklearn 2. First, we split the dataset into 10 parts, and the parameter of suffer is true. And then we use RMSE to show the result of 10 cross validation. And after that, let's look at the task 3. For the task 3, we need to argument 2 arbitrary data size and include the number of their recalls. And to find how to argument them is something you need to search and realize on ourselves. The argumentation result should include 5 times more data than the original data sets. Okay, in this part, we also load the data sets, and the new one is divided and win. Okay, we load the data size and the size x and y for each one. After that, we define a function to finish the argument to increase the number of recalls, and we do the random normal to each x, and use it to use the concat to get the increased data of x and y. Okay, after that we build 5 data size for iteration, and use I in range 5. Let's run the result, run the code, and get the result. Okay, for the original data set, and 2 times, 3 times, 4 times, 5 times. Okay, after that, for the tax 4, we need to measure the report and the exclusion time and accuracy of a play in XG boost, charge boost, cat boost, and light GBM. Okay, we use charge boost classifier from charge boost package and the cat boost classifier from the cat boost package and the light GBM package, and use the time to get the exclusion time. Okay, now here we use one data size as an example, and in the result we can find the code used in each data size. Okay, for the first data size, we initialize models and use log loss to add the parameter in charge boost. Okay, here we build a list to store the results, name the result, and to split the data size into training and testing data. Okay, here is feed the model, use X training and Y training to do the prediction, and calculate the end time and start time. And here is the result. Okay, we also use the pandas to do a data frame. Or it's used to like the result, make the result look like a table. Okay, let's run the code. It's finished. We can saw that for the data set original about iris, we can saw the XG boost, cat boost, like GVM, and here is 2 times, 3 times, 4 times, and 5 times. Okay, for the result, we have a comparison and summary the results. For the exclusion time, the XG boost generally like has the shortest time, and especially on the summer data size, as the size of the data set increasing, the time goes, but not as speedily as the others. And for the cat boost, it has the longest time among the 3 models. It may be due to these both classifier preferring more computation when deal with the categorical filters and compare the data, complex data. However, the increasing time with the size of the data set is not as pronounced. Okay, for the light GBM, its conclusion time is between XGBoost and CutBoost, being very quick on some smaller data size, but showing a significant increasing as data size get longer. It's important, I think. Its next is accuracy. For the XGBoost, it has a high accuracy across all data size, but execute nearly speed on the iris and win data size. And the CutBoost achieves the highest accuracy on most data and shows stability when dealing with the augmented data set. And the light GBM is similarly high accuracy to XGBoost and achieves 100% accuracy on some data sets, like the okay, so the result like in the win data site. Okay, in summary, on small data sets, all 3 models are capable of quick training and providing high accuracy results. through cat boost taking longer to training. And with augmented data size including the increased data, the XGBoost and Light GVM have a slower increase in time, and at the same time, the cat boost is increasing in time is less significant, but still the longest overall. Okay, in terms of accuracy, all models perform exceptionally well across different data sizes. But cat boost and light GBM reach 100% accuracy in some cases. The post-augmentation, including better stability and robustness. And for the light GBMs, TAM grows more quickly on larger data size, possibly due to the overhang of its default histogram-based optimization at scale. We can solve the light GBM for in the console dataset. With not quiz only. This one is, for example, for the in the summary. That's all for my assignment 3. Maybe you have some. If you have some question about my assignment 3, please email to me. It's my pleasure to give you more details and do more distribution. Thank you.